Hello students, welcome to Maths class. In chapter 8 Quadrilaterals, today's topic is properties of a parallelogram. In our previous class we have discussed about types of quadrilaterals and their properties. Today we are going to discuss about properties of a parallelogram, where we are going to prove some theorems based on parallelogram. So for first, properties of a parallelogram, let's prove theorem 1. A diagonal of a parallelogram divides it into two congruent triangles. So given ABCD is a parallelogram and AC is its diagonal. To prove triangle ABC is congruent to triangle CDA. Proof. Since ABCD is a parallelogram, opposite sides are parallel. That is, AB is parallel to CD and AD is parallel to BC. Now we know that AB is parallel to CD and AC is the transversal. So angle BAC will be equal to angle DCA. That is, alternate angles are equal. So we'll take it as angle 1 and angle 2. Therefore, angle 1 is equals to angle 2, alternate angles. So let's take it as equation 1. Also, AD is parallel to BC and AC is the transversal. So angle BCA will be equal to angle DAC. Again, alternate angles are equal. So let's take it as angle 3 and angle 4. So we have angle 3 is equals to angle 4. We'll take it as equation 2. Again, they are alternate angles. So, in triangle ABC and triangle CDA, angle 1 is equals to angle 2 from equation 1. Angle 3 is equals to angle 4 from equation 2. And AC is equals to CA, which is common in both the triangles. Therefore, triangle ABC is congruent to triangle CDA by ASA congruence rule. Thus, diagonal AC divides parallelogram ABCD into two congruent triangles. So we proved the theorem that a diagonal of a parallelogram divides it into two congruent triangles. Now moving on to the next theorem. Theorem 2. In a parallelogram, opposite sides are equal. Given ABCD is a parallelogram, we need to prove that AB is equals to CD and AD is equals to CB. If we draw a diagonal here, we get two triangles, and if we prove the two triangles are congruent, then by CPCT we can show the opposite sides are equal. So let's construct joint AC. Now for proof, since ABCD is a parallelogram, AB is parallel to CD and AD is parallel to BC. Now AB is parallel to CD and AC is the transversal. So angle BAC is equals to angle DCA. Alternate angles are equal. So let's take it as angle 1 and angle 2. So angle 1 is equals to angle 2. Let's take it as equation 1 since they are alternate angles. Also, AD is parallel to BC and AC is the transversal. So angle BCA is equals to angle DAC. Again, alternate angles are equal. Let's take it as angle 3 and angle 4. So angle 3 is equals to angle 4. Alternate angles are equal. Let's take it as equation 2. So, in triangle ABC and triangle CDA, angle 1 is equals to angle 2 from equation 1. Angle 3 is equals to angle 4 from equation 2. And AC is equals to CA, which is common to both the triangles. Therefore, triangle ABC is congruent to triangle CDA by ASA congruence rule. This implies AB is equals to CD and AD is equals to CB by CPCT. Hence, opposite sides are equal in a parallelogram. Now moving on to the next theorem. Theorem 3. If each pair of opposite sides in a quadrilateral is equal, then it is a parallelogram. We understood that opposite sides are equal in a parallelogram. So, in a quadrilateral, if opposite sides are equal, then it's a parallelogram. That's what we are going to prove now. Given ABCD is a quadrilateral in which AB is equals to CD and AD is equals to CB. Prove ABCD is a parallelogram. ABCD will be a parallelogram if opposite sides are parallel. So we can show that opposite sides are parallel if their alternate angles are equal. To show alternate angles are equal, we'll take the help of congruence of triangles. So to get two triangles, we'll do some construction. So join AC to get two triangles. So construction, join AC. Now for proof, in triangle ABC and triangle CDA, AB is equals to CD. Given BC is equals to DA, again given, and AC is equals to CA, common to both the triangles. Therefore, triangle ABC is congruent to triangle CDA by SSS congruence rule. This implies angle BAC is equals to angle DCA and angle BCA is equals to angle DAC by CPCT. But these are pairs of alternate angles formed by transversal AC with AB and CD and AD and BC respectively and are equal. Therefore, AB is parallel to CD and AD is parallel to BC. Thus, ABCD is a quadrilateral in which both the pairs of opposite sides are parallel. Hence, ABCD is a parallelogram. So we proved three theorems. Till now, theorem 1, a diagonal of a parallelogram divides it into two congruent triangles. Theorem 2, in a parallelogram, opposite sides are equal. And theorem 3, if each pair of opposite sides in a quadrilateral is equal, then it is a parallelogram. So here you can observe, children, in a parallelogram, opposite sides are equal. In a quadrilateral, if each pair of opposite sides are equal, then it is a parallelogram. I hope you could understand this. Now moving on to the next theorem. Theorem 4. In a parallelogram, opposite angles are equal. So given ABCD is a parallelogram, we need to prove that opposite angles are equal. That is, angle A is equals to angle C and angle B is equals to angle D. Since ABCD is a parallelogram, we know that opposite sides are parallel. That is, AB is parallel to CD and AD is parallel to BC. Now, AD is parallel to BC and AD the transversal. So, angle A plus angle B is equals to 180 degree. Allied angles are supplementary. Let's take it as equation 1. Also, AB is parallel to CD and BC is the transversal. So, angle B plus angle C is equals to 180 degree. Again, allied angles are supplementary. So, we'll take it as equation 2. Now, from equation 1 and 2, angle A plus angle B is equals to 180 degree. Also, angle B plus angle C is equals to 180 degree. So, both are equal to the same thing. So, we can say that angle A plus angle B is equals to angle B plus angle C. So, B and B gets cancelled. So, we have angle A is equals to angle C. So, we got to know that opposite angles A and C are equal. Similarly, AD is parallel to BC and DC is the transversal. So we have angle C plus angle D is equals to 180 degree Again, allied angles are supplementary. Let's take it as equation 3. Now, from equation 2 and 3, angle B plus angle C is equals to 180 degree and angle C plus angle D is equals to 180 degree. So, both are equal to the same value, 180 degree. So, we can say that angle B plus angle C is equals to angle C plus angle D. Now, C and C gets cancelled. We have angle B is equals to angle D. So again, angle B is equals to angle D, that is opposite angles are equal. Thus, opposite angles are equal in a parallelogram. Theorem 5. If in a quadrilateral each pair of opposite angles is equal, then it is a parallelogram. Given ABCD is a quadrilateral in which angle A is equals to angle C and angle B is equals to angle D. Prove ABCD is a parallelogram. Here again, to prove ABCD is a parallelogram, we have to show that opposite sides are parallel. So using the given, that is opposite angles are equal, let's show the opposite sides are parallel. So for proof in quadrilateral ABCD, angle A is equals to angle C. Take it as equation 1, which is given. Angle B is equals to angle D. We'll take it as equation 2. Again it is given. So adding 1 and 2 equations, we get angle A plus angle B is equals to angle C plus angle D. Let's take it as equation 3. Also replacing B by D and D by B, we get angle A plus angle D is equals to angle C plus angle D. Let's take it as equation 4. Now, by angle sum property of a quadrilateral, we have angle A plus angle B plus angle C plus angle D is equals to 30 degree. Now, angle C plus angle D is equals to angle A plus angle B. So, substituting for angle B plus angle D from equation 3, we get angle A plus angle B plus angle A plus angle B is equals to 360 degree. That is twice angle A plus angle B is equals to 360 degree. So angle A plus angle B is equals to 360 degree by 2. Therefore, angle A plus angle B is equals to 180 degree. But angle A and angle B are allied angles formed by transversal AB with AD and BC and are supplementary. Therefore, AD is parallel to BC. Similarly, substituting for E and C from equation 4, we get twice angle A plus angle D is equals to 360 degree. That is replacing B by D and replacing C by A. So we get A, D and again A and D. So we get 2 times angle A plus angle D, which will be equal to 360 degree. Therefore, angle A plus angle D will be equal to 180 degree. But these two angles are nothing but the allied angles formed by transversal AD with AB and CD and are supplementary. We have AB parallel to CD. So this implies ABCD is a quadrilateral in which both the pairs of opposite sides are parallel. Therefore, ABCD is a parallelogram. So we have proved 5 theorems till now. So let's recall all the theorems once. The theorem 1, a diagonal of a parallelogram divides it into two congruent triangles. Theorem 2, in a parallelogram opposite sides are equal. Theorem 3, if each pair of opposite sides in a quadrilateral is equal, then it is a parallelogram. Theorem 4, in a parallelogram opposite angles are equal. And theorem 5, if in a quadrilateral each pair of opposite angles is equal, then it is a parallelogram. So here you can understand once again, in a parallelogram opposite angles are equal. So in a quadrilateral, if each pair of opposite angles are equal, then it is a parallelogram. Now moving on to next theorem. Theorem 6. The diagonals of a parallelogram bisect each other. Given ABCD is a parallelogram, its diagonal AC and BD intersect each other at O. To prove OA is equals to OC and B is equals to OB. Proof. Since ABCD is a parallelogram, AB is parallel to CD and AD is parallel to BC. Now, in triangle AOD and triangle COB, AD is parallel to BC and AC is the transversal. So, angle DAO is equals to angle BCO. Alternate angles. AD is parallel to BC and AC is the transversal. Angle DAO is equals to angle BCO. Alternate angles. Also, AD is parallel to BC and BD is the transversal. So we have angle ADO is equals to angle CBO. Alternate angles are equal. And AD is equals to CB. Opposite sides of a parallelogram are equal. Therefore, triangle AOD is congruent to triangle COB by ASA congruence rule. This implies AO is equals to OC and OD is equals to OB by CP/CT. Hence, diagonals of a parallelogram bisect each other. Theorem 7. If the diagonals of a quadrilateral bisect each other, then it is a parallelogram. Given ABCD is a quadrilateral, its diagonals AC and BD bisect each other at O. That is, AO is equals to OC, B is equals to BO. Proof ABCD is a parallelogram. Proof in triangle AOD and triangle COB, OA is equals to OC given, OD is equals to OB again given, and angle AOD is equals to angle COB, vertically opposite angles. Therefore, triangle AOD is congruent to triangle COB by SAS congruence rule. This implies angle DAO is equals to angle BCO by CP/CT. That is, angle ADC is equals to angle BCA. But these are alternate angles formed by transversal AC with AD and BC and are equal. Therefore, AD is parallel to BC. Similarly, taking triangle AOB and COD, we can prove they are congruent and show that AB is parallel to CD. So similarly, we can prove AB is parallel to BC. This implies ABCD is a quadrilateral in which both the pairs of opposite sides are parallel. Therefore, ABCD is a parallelogram. So, in a quadrilateral, if diagonals bisect each other, then it is a parallelogram. Till now, we proved the theorem 1. The diagonal of a parallelogram divides it into two congruent triangles. Theorem 2. In a parallelogram, opposite sides are equal. Theorem 3. If each pair of opposite sides in a quadrilateral is equal, then it is a parallelogram. Theorem 4. In a parallelogram, opposite angles are equal. Theorem 5. If in a quadrilateral each pair of opposite angles is equal, then it is a parallelogram. Theorem 6. The diagonals of a parallelogram bisect each other. And theorem 7. If the diagonals of a quadrilateral bisect each other, then it is a parallelogram. From these theorems, we can understand that in a quadrilateral, if each pair of opposite side is equal, or each pair of opposite angle is equal, or if its diagonals bisect each other, then it is a parallelogram. So along with this, there's another criteria for a quadrilateral to be a parallelogram. That's a theorem 8. A quadrilateral is a parallelogram if one pair of opposite sides is equal and parallel. Given ABCD is a quadrilateral in which AB is parallel to CD and AB is equals to CD. Prove ABCD is a parallelogram. So we know that it's a parallelogram, both the pairs of opposite sides are parallel. So we need to show another pair of opposite side is parallel. To show this, we need a pair of alternate angles which are equal. So for that, let's take the help of congruent triangles. So let's construct to get two triangles. So construction, join AC. Proof in triangle ABC and triangle CDA, AB is equals to CD given. Now AB is parallel to CD and AC is the transversal. Therefore, angle BAC is equals to angle DCA. That is, alternate angles are equal. Now AC is equals to CA, which is common to both the triangles. Therefore, triangle ABC is congruent to triangle CDA by SAS congruence rule. This implies angle BCA is equals to angle BAC by CPCT. But these are alternate angles formed by transversal AC with AD and BC and are equal. Therefore, AD is parallel to BC. Thus, ABCD is a quadrilateral in which both the pairs of opposite sides are parallel. Hence, ABCD is a parallelogram. So we understood that if one pair of opposite sides is parallel and equal in a quadrilateral, then it is a parallelogram. Here we have proved the theorems related to properties of a parallelogram. We understood the criteria which makes a quadrilateral a parallelogram. Using these theorems, let's solve problems in our next class, students. Till then, take care and be safe. Thank you, students.